Nothing touched this steel drum. No hammer, no press. We only pumped out the air inside, and the sky itself crushed it flat. The atmosphere leans on every square meter of everything, with a weight of about 10 tons. You never feel it, because it pushes outward from inside you too. But truly empty a container, and you wake up one of the most violent forces in your everyday life. This is the story of the perfect vacuum. For most of history, people believed a true void was impossible. Nature, they said, abhors a vacuum. Then in 1643 in Florence, Evangelista Torricelli filled a glass tube with mercury and stood it upside down in a bowl. The mercury slid down and stopped, about 76 centimeters up. Above it hung a small pocket of nothing, the first sustained laboratory vacuum a human being had ever made. A few years later, Otto von Guericke, engineer and mayor of Magdeburg, built the first vacuum pump, and in 1654, he staged the most theatrical physics demonstration of his century. 2 copper hemispheres pressed together, pumped empty. Teams of horses hauled in opposite directions, by some accounts as many as 30, and the sphere would not open. Then he turned a valve. Air hissed back in, and it fell apart in his hands. The void wasn't holding it shut. The whole weight of the sky was. Fast forward 3 centuries to a field in Sandusky, Ohio. This is NASA's space power facility, the world's largest vacuum chamber. An aluminum vault 30 meters across and 37 meters tall, 22,653 cubic meters, that pumps down below 4 millionths of a torr in about 8 hours. They test entire spacecraft in here. And in 2014, for a BBC program, the physicist Brian Cox stood inside and released a bowling ball and a feather together. With the air gone, nothing was left to slow the feather down. They fell side by side and struck the floor at the same instant. Remove the air, and the heaviest and lightest things fall as one. So, how do you actually empty a room? At sea level, an air molecule flies just 70 nanometers before smacking into another one. Thin the crowd, and the survivors fly further and further between collisions, until in a good vacuum, a molecule almost never meets another molecule at all. It just ricochets from wall to wall, alone. And that changes the game. You can no longer suck air out like a fluid. You have to hunt molecules one at a time. No single pump can do it. It's a relay. A roughing pump drags out the bulk, then a turbomolecular pump, a turbine that bats individual molecules downward, blade by blade. Open it to ordinary air, and it simply stalls. Ion pumps and cryopumps trap the last stragglers, and still you are not done, because the walls fight back. Open a chamber once, and a film of water clings to every surface inside. It evaporates too slowly to ever pump away, so you bake the whole chamber like an oven for days. Even then, the steel keeps breathing gas from within. Engineers call it outgassing. Go deep enough, and the enemy isn't the air. It's the vessel you built. So how empty can we go at scale? In the desert of Washington State, the LIGO Gravitational Wave Observatory holds 10,000 cubic meters of vacuum at 1 trillionth of an atmosphere. Remember episode 1? Those 40-kilogram mirrors? They hang inside this. No air to carry sound. No molecules to jostle the beam. That is how they hear space-time ring. LIGO calls its vacuum one of the largest and cleanest in the world, surpassed only by one machine. Under the border of France and Switzerland, the Large Hadron Collider is the biggest operational vacuum system in the world. 104 kilometers of piping, and beam pipes as empty as interstellar space. Almost as rarefied as the surface of the moon. Your world quietly runs on vacuum too. Chip machines print with a light that air would swallow. The clocks that steer GPS toss their atoms through it. Even the kilogram is now weighed inside one. And then there's the benchtop frontier. In cryogenic traps a few degrees above absolute zero, physicists have reached about a 10/trillionth of a torr, and by indirect measurement, lower still, roughly 100 particles left in a cubic centimeter. One of the emptiest boxes human beings have ever made. Now, hold that number. At sea level, that same cubic centimeter holds about 27 billion molecules. And yet, between the galaxies, space carries less than 1 atom per cubic meter. Our very best box is still roughly 100 million times more crowded than the emptiness overhead. The universe out-empties every machine we have ever built. Perfection, it turns out, was never in our direction of travel. So, could we finish the job, pump out those last 100 particles, and reach the perfect vacuum? No. And not because our pumps are weak, because empty itself isn't. In 1948, the Dutch physicist Hendrik Casimir predicted something absurd. Take 2 uncharged metal plates, face them together in a void, a few nanometers apart, and the nothing between them will push them together. The vacuum hums with quantum fluctuations. Even absence has a pressure. For decades, it stayed a prediction. Then, in 1997, Steve Lamoureux measured that push, and it matched the theory to within 5%. Every perfect object in this series is a fight against a last imperfection. The vacuum is the only one where physics itself says you may approach forever and never arrive. Because empty out everything, and nothing was never empty at all.